Advanced concepts of modeling in artificial intelligence. Overview. Learning objectives. By the end of this unit, you will be able to understand the difference between artificial intelligence, machine learning, and deep learning. Learn key data terms, data, dataset, features and labels. Identify types of AI models. Explore rule-based AI systems with real-life examples. Know advantages and disadvantages of rule-based models. Understand types of learning. Understand neural networks and their structure. Understand how artificial neural networks and convolutional neural networks and learn using weights, biases, and backpropagation. Know the advantages and real-life applications of artificial neural networks and convolutional neural networks. Revisiting artificial intelligence, machine learning, and deep learning. Before we dive into understanding the differences and relationships between artificial intelligence, machine learning, and deep learning, let us first explore each concept individually. By examining artificial intelligence, machine learning, and deep learning separately, we gain a clearer perspective on how they interconnect, complement each other, and play vital roles in modern technology. Let's begin our exploration. Differentiate between AI, ML, and DL. Now, let us explore how artificial intelligence, machine learning, and deep learning differ and connect. Artificial intelligence. Artificial intelligence is the science of making machines smart. In simple words, artificial intelligence is when computers or machines are made to think and act like humans. It means giving machines the ability to learn, solve problems, and make decisions just like people do. Let us clearly understand with examples. Example 1. Using a Google Assistant or Siri on a phone. When you ask, "What is the weather today?" or "Play a song," it understands your words and gives a smart reply. That's artificial intelligence at work. The phone listens, understands, and answers just like a human helper. Example 2. Many Indian farmers now use an artificial intelligence app to know the best time to plant crops or when it might rain. Machine learning. Machine learning is a part of artificial intelligence. Machine learning is teaching computers or machines to learn from data and improve over time without being programmed directly for every task. This involves several steps as displayed in the second image. In simple words, we humans learn from experience and machines learn from data. Example. YouTube shows you videos based on what you watch. If you often watch cricket highlights or any cartoon shows, it learns your interests and suggests more cricket videos or cartoon videos. This is machine learning, learning your choices and improving recommendations. Deep learning. Deep learning is a part of machine learning. It uses neural networks with many layers to analyze huge data sets. Deep learning can solve more complex problems, such as recognizing faces or driving cars. Example. Face recognition in smartphones and voice assistants Like Alexa, use deep learning to understand images and speech. Common data-related terminologies. Some common terminologies related to data in the context of machine learning and deep learning are: data. Data is raw information collected from various sources, like images, texts, numbers, or audio. It is used to train artificial intelligence models. Example: student scores, weather reports, or pictures of animals. Dataset. A dataset is a collection of data organized in rows and columns. It is used to train, test, and validate artificial intelligence models. Example: a spreadsheet of student names, marks, and attendance is a dataset. Features. Features are the individual parts of the data used to make accurate predictions. For instance, when assessing a student's performance, important features may include their grades, the number of hours they dedicated to studying, and their overall attendance record in class. Example: in the context of weather application, the essential features might include current temperature, the level of humidity in the atmosphere, the speed of the wind. Labels. A label is the output or result that we want the artificial intelligence to predict. In supervised learning, the model learns from input features and the correct label. Example: predicting whether the student will pass or fail based on study hours. Modeling. Types of artificial intelligence models. There are two types of artificial intelligence models: rule-based models, learning-based models. Rule-based models. Rule-based learning models are basic artificial intelligence systems that work by following fixed rules set by humans. They make decisions or complete tasks using these rules. These models are good for solving simple and direct problems and are easy to understand. To understand more clearly, let's look into an example of traffic signal system. In a rule-based AI model, the decisions are made using predefined rules like if-then statements. A good example for rule-based artificial intelligence is a traffic signal system. Imagine a set of traffic lights at an intersection. The lights follow strict rules. If the traffic light is red, then cars must stop. If the light is green, then cars can go. If the light is yellow, then cars should slow down. Rule-based AI model follows predefined instructions created by humans. It doesn't learn or adapt, but it reliably performs tasks according to the rules it is given. Rule-based approach components. Knowledge base. Inference engine. User interface. Applications. Knowledge base. Knowledge base means a place where all the rules for a system are stored. These rules help the system know what to do. Let us understand the concept clearly by taking an example of a school security system. Example: let us consider the rules followed in school security system include: if it's a holiday, then keep the main gate locked. If the entry is after 8 p.m., then ask for an ID card. Inference engine. Inference engine acts like brain of the rule-based model. It looks at the rules stored in the knowledge base system and uses them to understand and solve a problem or a given situation. For example, If a visitor enters at 9 p.m., then the inference engine applies the rule to check ID card. User interface. User interface allows the user to interact with AI, input data, and view results. For example, a visitor enters their name into a digital check-in system at the entrance. Applications of rule-based model. Home automation system. If the temperature of room is below 10 degrees Celsius, then turn on the heater. If the main door is open for more than 10 minutes, then raise an alert. Banking chatbots. If the user types "forgot password," then send password reset instructions. School library management. If the library book is overdue by more than 7 days, then charge a fine. Now, let us learn the advantages of rule-based model. Simple to understand. Easy to read and interpret because rules are written in if-then format. Transparent and explainable. Decisions made by the model can be easily explained by showing the rules used. Fast for small data sets. Works quickly when there are fewer rules and less data. Controlled output. The outcome is predictable because it follows fixed rules. No training required. Does not require a training phase like machine learning models. Just create rules manually. Now, let us learn the disadvantages of rule-based model. Hard to scale. As the number of rules increases, it becomes difficult to manage. Lacks learning ability. Cannot learn from new data or improve automatically. Limited flexibility. Only works well in situations that match predefined rules. Time-consuming rule creation. Creating all the rules manually takes a lot of time and expert knowledge. Not suitable for complex problems. Cannot handle problems with too many variables or hidden patterns. Learning-based models. In a learning-based artificial intelligence model, the machine learns from examples in the same way as humans learn from experience. Instead of strictly following a set of rules, like the rule-based model, these learning-based models study data, find patterns, predict outcomes, and improve over time, without being explicitly programmed for every situation. The more data they process, the better they get over time. To understand more clearly, let us look into examples. Examples of learning-based model. Example 1. Game artificial intelligence. The artificial intelligence improves its gameplay by playing against people, and it also learns from past moves to get better at winning. Example 2. Self-driving cars. Artificial intelligence models learn how to drive safely by studying roads, traffic signs, and other cars. Each of these artificial intelligence systems keeps learning from data to improve over time, just like a student who learns from studying and practicing. Learning-based models approach. The learning process in artificial intelligence involves 3 steps. They include data collection. The artificial intelligence is trained on a dataset containing relevant examples for the task or problem it needs to solve. For instance, if the objective is to detect spam emails, the dataset will consist of various examples of spam and non-spam messages. Training. The artificial intelligence model analyzes the data and tunes its internal parameters to recognize patterns. It utilizes algorithms to learn from the provided examples. In case of detecting spam emails, the model identifies characteristics such as suspicious links, misleading subject lines, and unusual sender addresses. Testing. Once the artificial intelligence training is done, it is tested with the new data to check if it recognizes correct patterns. If it does, then it will be used in real-world tasks. Applications of learning-based models. Some of the real-world applications of learning-based models include language translators. Google Translate uses learning-based artificial intelligence to translate between languages. Online shopping suggestions. E-commerce sites recommend products based on your browsing habits. Face unlock in phones. Learns your face from images to unlock the phone. Chatbots for customer support. Trained to answer common customer queries. Advantages of learning-based models. Adaptability. These models adapt to new data and improves as more data is added. Versatility. They can help solve many different kinds of problems. It can be used for language translation, speech recognition, etc. Accuracy. Becomes very accurate when trained well. Efficiency. After training, these models can do tasks more quickly than people. Disadvantages of learning-based models. Data dependency. Require a lot of high-quality examples to learn effectively. Computational power. Training these models takes a lot of time and uses many resources. Bias. If the data provided in training these models are poor or biased, then the model may produce wrong results. Complexity. Difficult to understand the internal workings of some artificial intelligence models. Types of learning-based artificial intelligence models. Mind map for types of learning-based AI models. There are 3 types of learning-based AI models. Supervised learning, unsupervised learning, reinforcement learning. Supervised learning. Supervised learning is a machine learning technique in which models are trained using labeled data, which means each input has a corresponding correct output. For example, imagine teaching an AI to identify animals. Provide pictures of animals along with labels. Picture 1, elephant. Picture 2, camel. Picture 3, cow. When you show the AI a new picture of cow, it identifies correctly based on what it had learned in training. Next, we will look into different types of supervised learning, an important part of machine learning where models learn from labeled data. Now, let us learn about subcategories of supervised learning. Supervised learning is categorized into 2 types: classification model, regression model. Classification model. This model predicts categories or labels. For instance, it answers questions like, how warm or cold will it be tomorrow? Let us take another example. Face ID on your phone classifies whether the detected face matches with yours or not. Regression model. In regression supervised learning, model predicts numerical values like temperature or price. For instance, what will be the predicted temperature in Fahrenheit tomorrow? Let us take another example. What will be the price of a house with 3 bedrooms? Unsupervised learning. Unsupervised learning is a machine learning technique in which AI models are trained using unlabeled data. The model tries to discover patterns or groups on its own without knowing the correct answers in advance. For example, in the given image, the model analyzes animal data and classifies them based on their traits and behavior. These classifications may correspond to different species of animals, which enables the machine to organize animals without the need of predefined labels or categories. Unsupervised learning is divided into two categories of algorithms: clustering and association. This method groups similar data points together based on similar characteristics without knowing the group names. The AI decides how many clusters are needed based on the data. Examples include customer segmentation, document grouping, and pattern recognition. Let us learn in detail about the customer segmentation example. Examples: online stores organize shoppers into different groups based on what they browse or buy. AI classifies customers into groups based on spending habits. Group 1, tech lovers. Group 2, fashion shoppers. The AI doesn't know the individual identities, but it can group similar ones together. Association is a subcategory of unsupervised learning that focuses on finding relationships between variables in large datasets. It identifies patterns, correlations, and dependencies between different elements without predefined labels. Examples: finding frequently bought items together in a supermarket. Hospitals use association learning to detect disease risks early and provide better treatments. E-learning platforms, like Digital Teacher, use association learning to suggest content based on student activity. They study how students interact and find patterns in their learning behavior to provide better recommendations. Examples: students who watch video lessons repeatedly often score higher in quizzes. Those who complete practice tests tend to perform better in final exams. Learners engaging with discussion forums may have better conceptual understanding. Reinforcement learning. In this approach, the artificial intelligence learns by trial and error. It gets rewards for correct actions and penalties for wrong ones. Over time, it learns the best strategy. Examples are a game playing artificial intelligence that improves by playing again and again, like AlphaGo. Self-driving cars learning traffic rules through simulations. Training a robot to walk. Reinforcement learning in self-driving cars. Self-driving cars use reinforcement learning to navigate safely and efficiently. The artificial intelligence learns through trial and error by interacting with its environment and receiving feedback in the form of rewards and penalties. If the car stays in its lane and follows traffic signals correctly, it earns a reward. If it breaks a traffic rule, like crossing a red light or getting too close to another vehicle, it receives a penalty. Over time, the artificial intelligence refines its driving decisions to maximize safety and efficiency, just like a human driver learning to drive through practice. This approach helps self-driving cars improve their navigation, making better real-time decisions while adapting to different road conditions. An artificial neural network is a computer system inspired by the human brain. It has small units called neurons that work together to learn from data, spot patterns, make decisions. Subcategories of deep learning. Now, let us learn subcategories of deep learning artificial neural networks. An artificial neural network is a computer system inspired by the human brain. It has small units called neurons that work together to learn from data, spot patterns, make decisions. An artificial neural network is used for image recognition. Example: finding faces in photos. Language understanding. Example: chatbots. Weather or stock predictions, etc. Layers in neural network. A neural network is made up of 3 layers: input layer, hidden layer, output layer. Input layer. Raw data is given as input from outside. This data is passed on to the next layer. Example: if the task is to identify fruits, the input given might be the color, shape, and size. Hidden layer. In this layer, the actual learning and processing is done. Hidden layer can have one or more layers. These layers find patterns in the input data. Example: a hidden layer might learn that the fruit which is red and round is an apple. Output layer. The output layer provides the final classification or prediction based on the processed data. For example, after analyzing color, shape, and size, the model determines this fruit is an apple. Now, let us learn the advantages of artificial neural networks. Learn from data. Artificial neural networks can learn patterns from large amounts of data. They improve over time as they get more examples. Example: an artificial neural network learns to distinguish between dogs and cats by analyzing multiple images and identifying differences based on features like shape, color, and fur patterns. Adaptability. Artificial neural networks can adapt to changes in the data. They are useful in solving real-world problems where rules are not fixed. Example: a weather prediction model can adjust as seasons change. Handle complex problems. Artificial neural networks can solve tasks that are too hard for rule-based systems. They can detect patterns that humans might miss. Example: recognizing handwritten text or detecting diseases from X-rays. Automation. Artificial neural networks make decisions automatically by learning patterns without requiring detailed step-by-step instructions for every task. Example: an artificial neural network learns to recognize spam emails by analyzing patterns in messages and automatically filtering out unwanted emails. Work with incomplete or noisy data. Ants can still give good results even when some data is missing or not perfect. Example: recognizing a face even if it's slightly blurry or partially covered. Convolutional neural networks. A convolutional neural networks is a special kind of neural network designed for images and visual data. It automatically detects edges, colors, shapes, textures. Where are convolutional neural networks used? Convolutional neural networks are used in face unlock in phones, detecting diseases in X-rays, sorting images in Google Photos. Structure of a convolutional neural network. A convolutional neural network has multiple layers, each with a specific role. These layers help the network understand images, step by step. Convolutional layer. Activation function. Pooling layer. Fully connected layer. Output layer. Convolutional layer. Convolutional layer is the first and most important layer in convolutional neural network. It uses small filters to slide over the image and pick up patterns such as edges, lines, textures. The output is called a feature map or activation map. Example: a filter may detect the straight edge of a road in a traffic image. Activation function. After identifying patterns, we use an activation function like rectified linear unit to help the network learn complex, nonlinear relationships. Rectified linear unit acts like a switch. It keeps only the important signals while filtering out unnecessary ones. Example: imagine you are looking at a blurry picture of a dog. Your brain automatically ignores the blurriness and focuses on the dog's shape, eyes, and fur. Similarly, rectified linear unit helps a neural network focus on key image details while ignoring irrelevant parts. Pooling layer. Pooling reduces the size of an image while preserving key details, helping the neural network process data faster and more efficiently. This improves accuracy, even if the object in the image moves slightly. There are two main types of pooling operations. Max pooling selects the maximum value within each reach region as the output. Average pooling calculates the average of all the values in a pooling region. Example: imagine a system detecting dogs in images. Pooling ensures the artificial intelligence focuses on important features like ears and fur, even if the dog is in different positions. This helps the model recognize dogs correctly, regardless of slight movements. Fully connected layer. A fully connected layer in a convolutional neural network is the final step before the output layer. Here, the network makes decisions based on learned features. Earlier layers detect patterns like edges, colors, and shapes. The fully connected layer combines all the important features into one decision. The fully connected layer is then connected to a softmax activation to produce the class scores. Fully connected layer is a flattened layer. In a fully connected layer, nodes from one layer connect to every other node in the next layer. Example: imagine a convolutional neural network trained to recognize animals. In this, convolutional layers detect features like fur, ears, and tails. Pooling layers simplify the image while keeping important details. The fully connected layer analyzes everything and concludes, this is a dog. Output layer. The output layer of the convolutional neural network is the final stage, where the network makes its prediction based on all the learned features. Typically, the activation function is set to return values between 0 and 1, indicating the network's confidence in associating the input image with a class. A convolutional network classifying horses, zebras, and dogs assigns probabilities to each category for a given image. These probabilities represent how likely the image belongs to each class. For instance, if the network outputs 70% for zebras, 20% for horses, and 10% for dogs, it suggests that the input image is most likely a zebra. Advantages of convolutional neural networks. Automatic feature extraction. Advantages of convolutional neural networks: automatically learn important features from images without needing specific instructions. The network identifies edges, shapes, and patterns on its own. For example, you don't need to explain what and how a dog looks like. The convolutional neural networks analyzes dog images and learns to recognize them through patterns it discovers. Translation invariance. Advantages of convolutional neural networks: can recognize objects even if their position or orientation changes in an image. They can detect the same object, whether it's in the center, at the corner, or slightly rotated. For example, a traffic sign remains identifiable regardless of whether it is upright or slightly tilted. Reduced complexity. Advantages of convolutional neural networks: use pooling layers to reduce image size while preserving key features. This optimization makes the network faster in processing, more efficient in memory usage, better at learning patterns. Example: instead of analyzing every pixel, the convolutional neural networks focuses on the most relevant details, similar to how humans recognize objects by noticing essential features. Artificial neural networks. What is a neural network? A neural network is a computer system designed to function like the human brain. It consists of multiple layers of interconnected nodes that transmit information. Similar to how our brain learns from experience, a neural network improves its understanding by processing data. Each node carries out a specific task, such as detecting shapes or colors in an image. By working together, the layers help the network make intelligent decisions. There are three main layers. Input layer takes in raw data, like an image or a number. Hidden layers analyze the data by recognizing patterns. Output layer provides the final result, such as identifying whether the image contains a cat or dog. Example: the input layer receives pixel data from the image. The hidden layers analyze key features like tail, wings, and beak. The output layer confirms the result by stating, "It's a bird." Now, let us learn about the benefits of artificial neural networks. Learns by studying examples similar to how humans do. Identifies patterns and objects within images. Applied in everyday life, including image recognition, speech detection, and self-driving cars. How does an artificial neural networks make decision? Artificial intelligence in neural networks learns by giving different levels of importance to inputs and adjusting them over time. If it makes a mistake, it updates these weights to improve, just like how we correct errors when learning. This process is called training. Imagine a student solving math problems. After each test, the student reviews mistakes, learns from them, and improves for the next test. Similarly, a neural network compares its answer with the correct one and makes changes to get better. This process is called backpropagation. An artificial neural network analyzes data in multiple layers to recognize patterns. For example, when classifying whether the image is of a cat or a dog, the network gradually learns from features like ears, nose, fur to make an accurate decision. How artificial neural networks learns to identify an image. Step-by-step process. Step 1. Input data. Step 2. Input layer. Step 3. Hidden layers. Step 4. Weights and bias. Step 5. Training the artificial neural networks. Step 6. Output layer. Step 1. Input data. The artificial neural networks receives an image as input. This image is divided into small units called pixels. Each pixel holds a single intensity value in grayscale images, while in color images, it is represented by 3 values: red, green, and blue. For example, a 32 into 32 image of a cat or dog would have 32 into 32 pixels or 3072 features if colored. Step 2. Input layer. Each pixel value is passed to the input layer of the artificial neural network. Each neuron in this layer processes a single pixel and forwards it to the subsequent layer. Step 3. Hidden layers. Hidden layers in an artificial neural network play a crucial role in detecting key features within an image. In the case of cat and dog, the neurons in hidden layers will start to recognize features like: for cat, pointed ears, whiskers, small nose. For dog, floppy ears, bigger nose, tongue out. The hidden neurons emphasize important features by utilizing weights, bias, and activation function. Step 4. Weights and bias. Each neuron in the hidden layers receives inputs from the preceding layer, multiplies them by weights, adds a bias, and processes them through an activation function. For example, if pointed ears often mean cat, the weight for that feature becomes higher. Step 5. Training the artificial neural networks. Initially, the artificial neural networks doesn't know what a cat or a dog looks like. During training, images with predefined labels are input into the network. The network then evaluates its predictions against the actual labels and determines the error. Using algorithms like backpropagation, the weights and biases are adjusted to minimize the error. Step 6. Output layer. After the hidden layers, the final output layer determines the result. For this task, the output layer could have 2 neurons. One for cat, one for dog. The output neurons provide probabilities for both. Example, if a section of image shares characteristics with a cat, the output could be probability for cat, 0.85. Probability for dog, 0.15. As the percentage for cat is higher, the artificial neural networks decides the animal is a cat.